Hello, this is Dan Allford, and you're listening to Dan's Cadre of Experts. We've got a couple of interesting people on today, Bam and Mohammed. Give us your full names.
My name's Shubam Bhakta, but I just go by Bam.
My name is Muhammad Ali Mohsin. And yes, it is Muhammad Ali.
I just met these guys. Y'all are both UH students.
Yes, sir.
You're down at the Sugar Land campus?
Down at the Sugar Land campus, yes,
Okay.
sir.
And I only met you guys a couple of days ago, and when I met you, I was handing you $1,000 check.
That was pretty insane, yes.
But the backstory is I was working with one of your profs. Which one down there?
Dr. Afrin.
Dr. Afrin down at Sugar Land, and they're working on a Formula SAE car, I believe.
Yeah, they're working on two.
Two of them, and I was helping them out with welding, and then somehow or another we got introduced. What's the backstory, guys?
The backstory is Dr. Afrin was like, your project's super cool. We should have you reach out to a person named Dan. So I go down to the shop in the lab, and then Carlos, our lab manager, was like, "Oh, Dan is like the super awesome guy. He is donating like blades, and if you fuck up the blades, then he said to charge you three times the
I bought you all because I went out to your school and none of the bandsaws are working because the blades are all broken. I go, this is not good, but no, I love what you guys are doing, and so then you hit me up for a fee because you got a really cool senior project.
Really cool senior project.
Yeah, and we're both race car guys. You know, I race in the National Auto Sports Association. And so, kindred spirits. And so I really liked your proposal. And so based on that, I agreed to, I don't think you even gave me a fee, did you?
I didn't know.
I just made up $1,000. So is $1,000 enough? Are you going to get this thing done?
Our current proposed budget is $3,200, and
so they still need money right at this point.
The good thing is that this is going into this project. I was like super duper considering on like whether I even want to do something advanced, something unique, something that's gonna like catch people's eyes, or should I just do something simple and go with another team, not be like a team lead, and I can use that extra time to like do like applications and further my career. But with those two options, I decided to like take the initiative and do something cool. If I am doing 5 years of engineering, I want it to be worth something. And this is like the something I wanted to
All right.
try.
Go ahead and tell us. What are you building?
So we came up with this super cool idea. It's called a dynamic rear aero wing.
Let's give everybody a little background. In most racing, you're not allowed to have movable aerodynamic features, right? Which I think is stupid because every Cessna that's ever flown has movable aerodynamic features, but they've made it illegal in most racing. So apparently you're ignoring all the rules.
Yep.
And you're going not just a single movable dynamic, but two.
Yeah.
We have dual axes. That is correct. As like time progresses, the main limitation of like why they don't allow movable wings in racing. This was like one of our first points of research. Is like, why hasn't anyone done this before, right? Like, if this is such a cool idea, where is it at? So, what we found is that a lot of racing series don't allow active aero due to like not only the complexity, but it's also like the cost behind the research.
And there's some concerns about safety because if they fail at an inopportune moment,
and that could be a very bad thing. Essentially,
So it's not that they're just keeping us from having fun. There's some underlying wisdom behind this.
What about on F1 though?
Yeah, and F1's starting to what do they call it? Drag reduction system, DRS.
Yeah.
And so how does that work?
How does that work? From my understanding, all they're doing is just they're reducing the total footprint that the actual wing has by like.
Yeah, they just open it up.
In line.
Yeah.
Yeah. And they only have specific points where they can enable DRS, and they only have a specific amount of time that they can enable it as well.
Yeah, it's very contrived rules, but at least there's some progress. But what you guys are doing is not only to control pitch, but roll.
absolutely.
Explain.
So the roll actually helps us do a couple different things. The main thing being is now we can have the downforce angle normal to the wing surface. So if the wing is rolled at 20 degrees, now that force vector is aiming towards one of the back wheels.
So you
not
can load
straight
either
down.
the left or the right tire.
So we can load the left or the right tire. And then there's a secondary benefit of this as well, where the lower side of the wing is now acting in a area of the car that's known as the
Dirty air, right?
The dirty,
dirty air, yeah, as a wake, the wake of the hardtop.
Mm-hmm.
So with the wake of the hardtop, you don't have a whole bunch of airflow going over it, so you're reducing the overall downforce on that side of the wing,
So you're turning off half the wing, so to speak.
which is very unique for sure.
Okay, so this is all well and good. How are you going to actuate it? Is there going to be like a lever in the car or something, or is this hydraulic, pneumatic? What are we doing here?
So that's actually a super cool part of the project as well. We do have like a few different options. We have went through this quite a few number of discussions as a team. We are going with electric actuators that we are getting from AliExpress. So we don't know how good they are going to turn out, but we're going to try it. We're going to try our best.
Have you bought them yet?
We're right about to. We're
How much
sending
are they?
emails. They are $550 each.
Each. Oh darn, you're a little short.
Plus shipping, which is $73.
Okay. They have sensors on them. You going to get any feedback on position?
They do, yeah. They have potentiometers
Good.
feedback.
Good.
So 0 to 5 volts, we can tell 0 volts is at its shortest length, 5 volts at its highest.
You can add that to your data acquisition.
Absolutely.
Outstanding.
Absolutely. The overall system actually has one of the fastest microcontrollers that we can find on the market.
What are you running?
We're running a Teen C. So essentially think of like your Arduino Mega, but I want to say 15 times faster in terms of clock speeds.
What in milliseconds? What are you running?
Milliseconds, it's 400 hertz, so we can do the math on that. Like 40 milliseconds, I think. 400 divided by... Yeah, something like that.
More like
Arduino
2
runs on 40?
milliseconds.
The Teen C, sorry?
500 would be 2 milliseconds. That's okay.
Okay, yeah.
Yeah.
Damn, that's very fast.
Well, not in our world. We're running 40 microseconds on our motion control.
Microseconds.
But I think that's plenty what you're doing. So, good. I'm just curious. Keep going. So now you can control the wing. You're going to be able to send it to different positions, or is this like a joystick control?
It's going to send it to different positions based on how we map it. So the way I'm thinking about it is, so because we're both car guys, we've definitely tuned a whole bunch of race cars before. Have you ever looked at like a fuel map to where it is like a 3-dimensional...
Hurt your brain.
Yeah, absolutely. So that's exactly the way I'm thinking about it in my head. So we're going to have like this 3-dimensional graph that is going to calculate like, how fast we're going, our lateral G's, how much brake pressure are we applying, and how much steering input we're applying. And we're doing this all through good motorsport grade sensors, such as running like a Bosch IMU and running AIM, the AIM data acquisition system. We're actually taking sensors from their motorsport level data logging system and then using them for our application.
So, how are we going to quantify success and failure on this? So you're going to build this wing. It's going to move back up and down, left and right. But how do I know whether you've accomplished anything?
That's a great question. I have over 200 hours of track experience, so I believe I can feel that, right? But we don't want that. We want to quantify it.
There you go. Thank you.
We want to measure this. So we actually have 4 different tests lined up for the end of our I guess testing phase. We're currently in our design phase at the moment. We're still designing, figuring out if the forces will work for the frame and the wing and the hinge and like how everything's going to move and rotate, especially because we don't have the actuators just yet, so we don't know where everything's going to line up and fit. But for our tests, that's going to be later, I want to say in August or September, so maybe like 5 to 6 months.
But we're going to measure lateral G's, right? And
Yes.
That's what racers care
Yeah.
about. How hard can you corner?
So we have 4 different tests lined up, and that is one of the big tests.
That is the test, in my opinion.
I think it's going to be a very good test for sure. We have mapped out the carousel at MSR.
Which is Motorsports Ranch here in Houston.
Yes, sir.
They're going to let you use the track?
We don't have confirmation of that just yet, but we are talking to the track owner up in New Caney for Speed Sports. They're a local small go-kart track. that people run.
What a Miata's like an oversized go-kart.
Basically.
Yeah, so you'll be fine. Go ahead.
We measure the track width in terms of Miatas. It's 3 Miatas wide.
That's plenty.
They
You can drift it.
absolutely, and they
We've done
actually do
that.
very exciting events that happen up there. Very exciting. They also race mini bikes up there too. Fun fact. So we have the carousel mapped out at MSR for our lateral G test, and then we have two double apexes at Speed Sports that we can totally use in terms of trying to maximize the, how many G's we can pull through those double apexes.
You're going to use accelerometers. You're going to use segment times.
We have IMUs already built in from Bosch too, so we know that they're going to be accurate and well, make sure our data is accurate essentially.
Then you're going to do a braking test.
A braking test, absolutely. So probably something from like 120 miles per hour to 0. Because the Miata is a non-ABS car, we can't keep it within that static coefficient of friction, because that's where we want to stay, right? We don't
Right. You lock the tires. You don't slow down as well.
Absolutely. So
Ask me how I know.
years of racing experience.
Right. The cars we race, we actually take the anti-lock brakes off. And so if you want to flat spot your tires, that's fine. But then you're right around the rest of the day going. Tup, 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 tup.
Oh no.
So no, it adds to the skill. So as long as you do multiple tests, I bet you can. And
Yeah,
Kind of average it out.
which one of y'all's faster?
That's
Depends
a
on
good question.
We're gonna find out.
my car's faster than him. Not the Miata though.
So we actually we should go a little bit into the background of
Do it.
like why we're here. Well, as y'all know, my name's Bam Bhakta. I used to be a technician for Porsche. So right out of high school, I actually went to trade school. Not only because I didn't want to go to college. I did want to go to college. I did love engineering. I started doing Arduino stuff and robotics and whatnot in high school. But I really loved cars, and I wasn't allowed to work on any cars. Just because, like, what's it called? It's just something that I wasn't allowed to do.
Cruel parents or what?
I mean, they have different mindsets. That's no problem. They've been supportive, my entire life. Very, very cool people for sure. But I wasn't allowed to work on cars, so I was like, you know what? Let me get professionally trained. I turned out to be really damn good at it. Really good.
You made a lot of money,
Made a lot of money at
but
Porsche.
you still weren't happy.
I still wasn't happy. I wanted to like actually make a difference, make a change. And I had like these cool ideas, but I didn't know how to put reasoning behind them. So that's why we're here now.
Sometimes you need a little math.
Exactly. Unfortunately, that tons of math. We've been going through like FEA and hand calculations and
What are each of your degree plans right now? What are you going to be when you grow up?
mechanical engineering technology.
Same thing.
Same
Yeah,
thing.
you-
Gotcha.
So when I moved back from the dealership life to go to college, which was a massive decision, looking at the opportunity cost of that, or like the lost opportunity cost, I don't even want to look at it. But when I moved back, I met Mohammed, and
Yeah.
Mohammed was always our like next door neighbor. He started working on his car one day, and I was like, "Hey, what you doing over there?"
And that's what it started all. It's like that was the beginning.
And then right after that, you started Lone Star.
So, for some background on me, my name is Mohsin, right? Muhammad Ali. I am not a senior. However, I am a new age and currently progressing in my degree, same as him.
Well, he says he's on the 5-year plan. What are you on?
Yeah, same thing, same
Okay,
one. I'm
gotcha.
just not I'm not a senior, and I'm not doing my senior design project. However, I do want to be involved in his senior design project.
That's why I wrote the check to him, not you, I guess.
Yeah, exactly.
Gotcha.
I don't touch any of that money. I am indeed very interested in engineering, specifically mechanical engineering or electrical engineering. I don't really care. I love engineering as a whole. Fantastic field.
And here's an application for it.
Yeah, and this is a fantastic application. And I think this is a fantastic opportunity to be able to learn a lot as well as get involved, meet a whole bunch of new people, and find out what I would want to do for my own senior design project as well.
So this is applied mechatronics with a way to quantify your results. I love it.
Yes, indeed so. And now what have I done? As Bam said, he saw me working on my car. We both have Mazda 3s. I don't even remember what I was doing. that made you interested?
Those are like 135 horse. What are they?
No. So we have the 2.5s. So
Oh.
those have 186. Okay, they're not.
Oh, you
Yeah.
got the big motor. Gotcha.
The big motor, and they're torquey. But it's a 4-cylinder. You can only get so much.
I've had a Miata.
That's true. I don't remember what I was doing on my car, but he came over. He started talking, and the rest is history, basically. And we meet basically whenever, and we talk about whatever. And I now, whenever I'm working on my car, he always comes by. He gives me some tips from his background as a tech, since I do know how to work with a screwdriver, but it was mainly for like small stuff.
Right. Well,
Since I did like electronics, phones, computers.
sometimes when you're unencumbered by formal training, you can do good things.
Yeah, exactly. so now I have all the tech tips for being able to work on a car, and I've done a whole lot of work to my car, and I wouldn't have been able to do it without his guidance.
So do you guys do track days
Yes,
All the
with
time.
Driver's Edge or with who?
We do it with the track casual.
with track casual.
Gotcha. I teach for the Edge, so
I've heard good things about that. They recently had one up in Austin, right?
we all over the state. So Coda, both motorsports ranches. But so how are you going to mount this wing? Is this going to be just to like a bumper hitch or to sheet metal? Or if I recall correctly, there's an advantage to having the wings coupled directly to the suspension, but that wouldn't be practical, would it?
Especially with the independent rear suspension, that would be like, I don't know.
I don't think it would do anything.
Well, no, the advantage is you don't compress the suspension.
I guess that's true. It would just go directly to the tires.
Yeah, but on a Miata,
And you wouldn't get any body roll benefit.
right.
Yeah.
Mm-hmm.
Yeah, that's mostly done on like drag cars where they can mount it directly to the solid axle in the rear.
Well, it makes sense to me, but you don't have that option, and I can't imagine doing that with an independent rear. But so, what are you hooking it to? The trailer hitch?
We had multiple options. Like if you don't mind me asking, what generation of Miata did you have?
I don't remember.
Was it the one with the pop-ups?
No, not pop-ups. Fixed lights.
Fixed lights? Did it have 5 lugs or 4 lugs?
5.
5. NC.
Yeah. NC Miata.
Okay, I trust you. I used to loan it to everybody. The Miatas are the ultimate track car, and so a half a dozen of my friends all got their first track experience in a Miata because no anti-lock brakes, no nannies as we call them. You know, the electronic yaw and control. So it's a driver's car. So I'm glad you're starting with a Miata. It won't disguise your results.
I think the Miata is like just a fantastic overall car too. I recommend it for anything, like even including like moving. You know, like the sky's the limit. You can drop the soft top down and you can move anything you want to move. It's just you gotta look up.
You can tow.
You can also tow. We actually drove my friend's NA Miata all the way up to Colorado with a motorcycle trailer. Kind of like what the Harley Davidson guys use. Very, very they're very cool, and we can make them practical.
Mm-hmm. Yeah, I had a trailer hitch installed on mine just to carry tires to the track.
Yeah, exactly. There you go. So as for mounting it, we ran through 5 or 6 different design ideas.
Good.
Our first idea was, why don't we just mount it to the factory tow points? I have something called a rear jack point. So if I need to change out my rear tires, all I have to do is jack it up from that one point. The way they made this jack point is they just took off the rear 2 tow hitches, tow points on the back, and they replaced them with a point and 2 additional extremely sturdy tow points. So if you get stuck out on track, they can pull you out, no problem.
That's required.
It's very sturdy, a very good thing to have in my opinion, and I love how I have a singular jack point in the back. So rear tire changes are super easy, adjusting coilover is also super easy, measuring stuff, it just makes life so awesome. I love every second of it. Now, did I want to take that off to mount the wing? I don't know. We definitely considered it. We actually bought a tow hitch with I believe it was a 1/2 inch square, a 1/2 inch receiver.
Maybe 1 inch.
Yeah, I think that's what it was. Yeah, that makes sense. But we bought one. We like rigged it up to the car and tried to see where we could get it to fit, and that would essentially replace the single jack point, but we could use the tow hitch receiver as a jack point as well. So it's really not that big of a deal.
Because you got a single pivot in the center, and it's 2-axis pivot, right? And then do you have rod ends on both ends of the actuators, or because they're going to need to move in all? Okay.
In all the directions, yeah.
All right. So you have three different spherical mounts
Yes.
on the wing and 3 on the chassis.
So what we ended up going with for like the mounting
Mhm.
is we just sandwiched a plate in between the factory crash bar and the car itself. We are actually talking to the people who are making the actuators at the moment, so they're gonna hand make them for us, which is pretty cool in China. So that's gonna be super super cool to see. We're going a little bit back and forth in terms of length and everything because the Miata is a pretty small car, so we needed to fit behind the car without hitting the ground. But we did option them out with Heim joints.
There you go. Spherical rod ends.
Yep.
That's the way to go. And so you'll be if you move them up, both up and down, then that strictly does pitch, right?
Yes,
But then if you have different lengths, that's how you're going to achieve roll control.
absolutely. And then a vast combination of that is gonna have like pitch and roll. So that's gonna be a very interesting thing to not only program but to determine like at what where do we want these forces to act, and like when we want them to act.
You're going to go so far as to tie it into the brakes.
Absolutely.
Okay, so when you hit the brakes, you're gonna throw in some pitch.
And then we have a brake pressure sensor from
Okay.
AIM. So not only are we
So it'll be proportional to braking.
exactly. So if we see like over 1,000 psi of brake force going to the front calipers, we know this guy's braking hard. Throw that wing up all the way at 60 degrees, and it's almost 600 pounds of drag force that's created. So that's definitely a lot of.
But it's actually going to be lightening the front end, right?
It will be lightening the front end, yeah. But hopefully we can utilize that and like distribute the brake pressure to the rear as well. So we have a on the fly adjustment on the Miata.
A rear brake bias.
Rear brake bias. So we can use that to our advantage. So make sure we're utilizing. So you know
But
all
that's
about
manual.
the grip circle.
Oh yeah, the traction circle.
Yeah, the trap. Yeah, there you go.
Mhm.
So we're gonna try to
Yeah,
utilize.
so if you do well, you'll have a nice, perfect. Well, except for acceleration, because you don't have any acceleration in a Miata.
Unfortunately.
So one quadrant will be a little lacking, but the braking and cornering, that's what you're trying to achieve.
Absolutely.
So what kind of tires are you going to run? Stock or slicks, or where are we going?
Okay, so I just got a brand new set of Kumo V730s.
Gotcha.
I used to run the Falcon 615Ks, which I'm sure you know all about. They're like your typical entry level track tire, endurance tire actually. They last forever and ever and ever. I think I got like 6-7 track days out of my 615Ks.
And that's along with driving and whipping around the neighborhood and whatever.
At legal speeds.
Of course, always legal.
I don't know if it can go.
You can't even go faster.
Fun Miata stuff, you know. But we're running Kumo V730s. I really love them. My daily tires are now Yokohama V701s, which is like a summer tire. I think 300 tread wear, 340 tread wear.
So as long as you use the same tire through all the tests, so it'll
Yeah.
We should be good.
doesn't matter. Are you going to play with wing height? Because you're intentionally going to be shadowing the wing in the dirty air, so that means wing height is a critical variable.
Absolutely. So we had a hard time calculating like what is the ideal height. We had a really hard time calculating that.
You'll never find. You'll have to do that empirically.
So our idea, after like having a difficult time calculating it, was like, let's throw in a CFD. And as engineering students, that's something that we should know, and that's something that like will be helpful in the future. So we should definitely go ahead and learn that.
But trying to model dirty air.
Yeah.
Well, the good thing is that the computer will do that for us. All we have to give it is boundary conditions, right? We want clean, laminar air going in, and then after the
Where does
car.
it separate?
Yeah.
Exactly.
Are you gonna run the top up?
No.
Hard top.
Yeah,
Oh, it's hard top.
Hard top, yeah.
Mhm.
So we can have that wake that is created from the hard top.
I'm amazed you fit in there with a helmet.
I'm surprised too. I had to do a little bit of cutting. We had to cut out the floorboard and drop it a little bit for sure.
You have a race seat?
I don't have a race seat.
Is that a stock seat?
Stock seat, but it has a whole bunch of modifications done to it. So we cut out a whole bunch of the foam. I really wanted to keep the stock seats because of the headrest speakers. Because of the headrest speakers.
Tell him just take out those speakers, put it in any other seat.
No, racing's all about that last little bit, and speakers aren't part of it.
No, definitely not. But my Miata does weigh. I had a corner balance and weighed at MSR. It came in at 2630, I believe.
With you?
Without me.
Okay.
That's pretty heavy for a Miata.
Get rid of those speakers. So you're putting all this aero in the rear of the car. You know, there's another end of the car, you know.
The front end, yep.
Yeah. So why not a wing in the front?
So that's something that we have definitely looked into. Like a front splitter or like a undercarriage, like full flat kit, to where we can make the undercarriage of the car completely flat to maximize downforce via
the rear diffuser. Yeah.
So-
I have one.
I know Mohammed's been doing a ton of research into like rear diffusers, aerodynamics. Actually, on his Mazda 3, this is kind of off topic, but it's super cool. On his Mazda 3, he's running Tesla wheels with the Aero caps on them.
Yeah.
Just for less drag.
Yes.
So yeah,
It does make a difference.
No, I'm with you. I race Formula Vs, and we have a great big 60 horsepower motor.
Wow.
And they're still pretty quick, but it was all about aerodynamics and conservation of momentum, and Miatas are very similar.
I agree, absolutely. No, I didn't know that. That's pretty cool. 60 horsepower?
Yeah, if you look back, it's actually a 36 horsepower motor because you can only run a 1964 or older 1200 cc motor with a 28 millimeter carb. And so the only way we even got 60 horse out of them, and that's at the crank, not at the wheels,
So it's even lower.
Oh yeah, there's
Man.
nothing at the wheels.
So basically, that's like racing go-karts.
Yeah, it is, but except you have a roll bar and seat belts, which I approve of. But
Okay.
you know, a 28 millimeter carb, that's about the size of your thumb, and so that's
Same one. I have the same one on my go-kart.
Well, but these are 1200 cc engines, you know, a single carb doing all that. But they're just trying to keep the cost down. But we produce you'd produce the 60 horse, but it was up near 7,000 RPM, so the life of them wasn't that long. But we were all about minimizing drag. So you're not minimizing drag here. You're going to be adding a ton of drag
Well, actually, we can minimize drag.
by
because-
flattening it out.
By
by
flattening
flattening
out.
it out.
DRS.
Is there any place you can check for maximum speed with and without the downforce? You'll have a track to do that?
Our legal road, you know what I'm saying?
Yeah, I'd like that'd be a cool piece of data. Just, you know, you might even be able to calculate the horsepower you burned up by the wing if you calculate the reduction in top speed.
I like that.
You
I
measure
like
the
that.
time.
100%.
Yeah.
Yeah.
Too
That's-
much fun.
That's an interesting question. I know the Miata it's like power limited, not gear limited. But as soon as you add like a turbocharger, or any type of like force induction system, I know some people use like centripetal superchargers. Some people use like dual rotor super ones. You know, so it's very cool. But as soon as you add anything like that, the gearing becomes a limitation. Just a cool fun fact that we're actually considering on going turbocharged or supercharged before the testing starts, so we can have like better numbers, and it's just always been a cool.
Don't do
fun
it. Just
factor.
go with stock motor. That'd be one less thing to worry about. And it won't blow up.
See, we like say that our current Miata has 3 working cylinders and 1 kind of dead cylinder. But it still does track days. It still does everything we needed to do. It just burns some oil.
And you're claiming 180 horse earlier. I don't think so.
No, that's for the Mazda 3. You get it
Mazda
right.
3, the Mazda 3, yeah.
The 2.5. This is a 1.8.
1.8 liter,
Yeah.
yeah.
Interesting. All right. So, do you have any delusions of selling this if it works, or is this just an academic problem, or what's the big picture here, or do you just want to get an A and a degree?
So after the engineering aspect of it, I think that's gonna be very cool. I don't have any aspirations of like selling the wing or like making profit out of it because I'm really doing this for the engineering aspect of it, right?
Good for you.
Um,
Too many of my students with the senior project say, "Oh, I'm going to build this. I'm going to be rich." I go, maybe.
this is like definitely for like the engineering aspect of it because once we have accomplished this, what we're trying to currently do, now we're more capable of doing something better in the future, right?
Oh, yeah.
Like we have
You're on the
run
right track.
into like these issues that we know how to fix, that we know how to tackle. So our next issue is going to be easier and better. I will say that like once this is a reality, going to Cars and Coffee is going to be a completely different ball game. I'm gonna have it like move, like do some cool maneuvers, just like driving at low speeds, and everyone's gonna be blown away. I can already tell. It's gonna be absolutely wild and very impressive.
Mm-hmm.
I might even be able to park in the supercar section. We don't know.
Excellent. All right, so what's the schedule on this thing? When are we going to see this car run?
Great question. Our current schedule is we have a month for design and our manufacturing plan. So from right now, we have a month. After that, we're going to go into the manufacturing of it, which we're going to ask you to help us out in terms of like cutting plate and.
How are we going to make the wing? You going to buy the wing?
That's a great point as well. We couldn't find a wing that has no airfoil. Because we don't want an airfoil.
You just want a flat plate?
Yeah.
Just a flat plate.
Okay.
This makes the calculations easier. Not only that, but if we really want no drag in the straightaway, we needed to cut through the air, not create any downforce, just no drag.
Yeah.
On the straights. So we can utilize our 90 horsepower Miata to like the maximum potential, or 3/4 of it at least, because it has 3/4 of the cylinders.
Yeah, but there's going to be a lot of load on this wing, and if it's too thin, it's going to flap.
That's true.
And so if it has some thickness, it should be rounded on the front and tapered on the back. So I'm not convinced that a flat piece is the way to go. Am I wrong?
You definitely make some good points. We have not measured out, but we have researched the stiffness of like carbon fiber and like different ways to lay it down and ways to make the wing stiff without adding too much weight. And we're looking into like carbon fiber spars and tubes that they use in the model airplanes. I used to be big into like RC cars and model airplanes and
Good training.
absolutely great training. That's where I got a lot of my like wiring skills and electronics. So going to tech school, people were scared of electronics. They're like, "Oh, that's like my worst topic," or like they were scared, right? Because you can't see electrons, but because
You can feel them.
you can feel them though for sure.
And then you can see whenever it smokes.
Especially nowadays.
You see 'em, yeah.
Especially nowadays with like all the electric cars, where it's like you have 400-volt systems, 800-volt systems.
It's lethal.
Yeah.
Absolutely. We have like 2-man teams working on the Porsche Taycans and stuff back when I was at the dealer. But
Why not 3 actuators? Then all of a sudden you can adjust height. Well, you're going to have one fixed point, right?
oh, that's true. Yeah.
Why not do 3?
Why not do 3?
Next point would be the hinge.
You can still have a hinge.
Oh, okay. I see what
See
you
what I'm saying?
Yeah, yeah.
We would put the hinge support on like another actuator. That's a great idea. That's a great idea. And
It would add complexity, for sure.
it would definitely add complexity.
I'm just the devil's advocate.
Yeah.
Because, I do think height is important. So if nothing else, you need to have multiple bolt points so you can try it at different heights. No, I'm just messing with you. I wouldn't do that, but that would be fun.
But that's a good idea, having multiple bolt points, or maybe we can what's it called? Have a couple different options for like the real world, which we will have plenty of sheet left. We like did some math and did some laying out of like the parts on like a one big sheet. I think we're using 1050 at the moment.
1050 what?
Steel.
So high carbon steel.
High carbon steel, yes sir.
So it's this very thin steel. You're building a knife.
3/16, yes sir.
Wow. And then when we attach to it, how are you going to attach, drill and tap, weld?
It's all going to be mechanically fastened together. So what we can do, especially for the testing, is we can drive the car there without the wing on it, and then after we test it, we can ensure that like it's not going to go anywhere. Then we can try to use it on public roads. But our first priority is safety. So we want to have this thing be easily removed and taken off and put it back on. And because this is an engineering project done by students, so I want to have.
You're not allowed to hurt anyone.
Yeah.
Are you going to put winglets on there to keep the air from spilling off the ends like you see on airplanes?
I do love the idea. We're not going to put winglets on it because during the roll and the pitch combination, the winglets were actually acting as even more drag, like a ton more drag, just because of the angle of how it's working.
I was thinking if you bend them, it also would stiffen it. That's all I was thinking.
I do like that too. Yeah.
Well, we've got a sheet metal.
You could just like give it a slight bend. How
Like
much drag would that give?
I mean, we could give it like a little bit of downforce.
Like you could find the trade off. Like for however much you bend it, how stiff will it be overall?
And like that's something we can definitely like put into the CFD and like verify or like visually see the airflow as well. I do know this one place in Houston that has like a car-sized wind tunnel that we might be able to use. So.
See, I think your wing's going to be too flexible. It's just sheet metal is very flexible. It needs to have some cross section.
You're talking about the frame or the wing itself?
The wing itself. I think it's going to tips will bend down. It's supported in the middle, and the tips will bend down. It'd be fascinating. Definitely
It
shoot
has
some
the two
video.
actuators though.
Well, yeah, but the actuators aren't at the ends.
That's true. Yeah, the actuators are somewhere in the middle.
Mm-hmm.
That's a great point. That's a great point. We might try to like because even though it's like 3/16 inch thick, we might be able to insert some like some like box sections in the middle. And I feel like with those carbon fiber spars, you can't underestimate the carbon fiber spars. Like these model airplanes, they'll pull like 3 or 4 Gs in the air, just doing wicked maneuvers.
Oh, okay. No, I get it now. Yeah, but that's the spars run down the width, the length of the what's going to stiffen it across the part.
You're talking about like from side mirror to side mirror, right?
Yeah.
So from side mirror to side mirror, it's going to be those really long spars. Those
Okay,
2 meter
very
long
cool.
spars.
All right. Well, I'm looking forward to seeing the data on this.
I can't wait. Especially as we dive deeper in every day, we're always working on something different. Just recently, I finished up the frame design, and we ran so many calculations, like by hand and through FEA. Obviously we have to verify our hand calculations, and like we found similar results in the FEA, but we ran everything from 1/4 inch plate high carbon steel to like our common A36 hot rolled stuff.
And let me guess, the deflection was the same.
No, it actually wasn't.
Yes, it is, because the modulus elasticity is constant.
Oh, sorry. Yes, it was. The yield strength was different. The factor of safety
right.
was different.
But the deflection is exactly the same. A lot of young engineers make that mistake. They'll be like, "Oh, we went to a harder material." Well, that don't matter.
Yeah, I believe we spoke about this last time. Where like aluminum, titanium, and steel.
They all have a lower modulus. You'll see more deformation. The only thing stiffer is carbon. Not all carbons, though.
I think Mercedes was doing not Mercedes. McLaren was doing something very similar, in terms of the way they wrapped their carbon fiber wing allowed deformation.
Yeah, difference between a radial tire and a bias ply tire.
Yeah.
It's identical.
So whenever they like tested it, they're like, "Oh yeah, your wing's good. It doesn't deflect." But whenever you actually load it with the aerodynamic forces during race day, now it's deflecting.
Very clever. I hate to see you waste a whole lot of time on the wing. I think you ought to just get a wing cross section that's readily available and put it on the car for stiffness. But you're having fun. Continue on.
Absolutely. And then that might be the end case as well, right? We're all doing this for the learning experience.
So we're cornering around a corner. Let's say we're turning left. So now the inside rear tire is light.
Yes.
Inside front tire is light. Mm-hmm. You've taken off the sway bar off the back of the car, right? so you don't have any sway bar.
Right.
So
no
that
sway bar.
doesn't aggravate the lifting of the inside tire. So you're trying to load the inside tire. So you're going to put the wing high on the left to try to control what roll
We're trying to put the wing high on the inside corner, so
Yeah.
yes, the left.
on the left.
Then that gives us more clean air going over it, and then it gives us our downforce vector normal to that. So it's going to be 20 degrees, essentially pointing at the wheel from the middle of the car.
Yeah, because when you're cornering hard, on my race car, I'll actually lift a front tire. Because all the weight's on the outside tires, right? And so you're trying to put some more weight on the inside tire, get it to do its fair share,
Mm-hmm.
and the wing's going to do that for you. You hope.
Yeah.
We hope so.
Good.
We
I
really
want
do.
to see the data.
So even though we're like focusing on a Miata, me and Mohammed, we both have Mazda 3s.
Yeah.
And we're absolutely whipping these, little economy hatchbacks on the track.
We definitely three wheel.
How do you think, like that would, or this wing would work on a Mazda 3? Do you think it's possible?
I think in your case, since you do have independent rear suspension, it would act differently from mine since I have a torsion beam. In my car, I tend to oversteer actually mid corner, especially if I have my summer tires in front. So I think it would, for me at least, it would just induce more understeer. I don't think it would be that useful. It would help definitely in braking when you just put it 60 degrees, right, and then you just have a ton of rear brake. I don't know how useful it would be on a front wheel drive car specifically.
'Cause I think I was watching like a whole bunch of Civics racing the other day, and every single Civic and Honda Fit, the back tire was just off the ground.
They want the rotation.
They do, yeah. I guess that makes sense, right?
Mm-hmm. So maybe this wing will fix it. I've never seen a car with aerodynamic roll control. So it'll be fun.
Definitely be super cool. I cannot wait. And the Cars and Coffee meeting's gonna be awesome too.
Excellent. Well, this was fun, guys. So I want to get you guys back on once this is running. You're going to bring back some data, some video and stuff. But what else did you want to cover today on this episode?
I actually wanted to cover something really cool, something that's like pretty important to me, is because this is like my first project that I'm leading at this level. I've learned so much about teamwork, project management.
Selling your project to sponsors.
Absolutely, right? Like we have the nice documents, something that makes it look pretty polished, and we're actually putting in the work too. So it's not only for show, but we're, at least myself, I'm staying up 3-4 a.m. every day, just absolutely grinding on this project. This is very important to me, and I want to make sure it works. But the biggest thing I learned about like management is that it's a completely different ballgame. I haven't learned anything that I'm currently learning ever before, and I'm really glad that I did end up choosing to do such a difficult and demanding project, because now I know where to like allocate people, like how to make my teammates not only like motivated but to keep them engaged. And every teammate has a role, or like a responsibility for sure, but they have an interest. That's like what I'm trying to say. They have an interest, right? And I found that lining up their interest with like a part of the project really helps.
Do you want electrons? Do you want steel? Everybody's different. Do you want software?
Absolutely.
It's a package. No, I say God favors large armies. So yeah, the more people you have working on this, the better you are. And if you can instill that sense of urgency and interest in people, they'll do great things.
And I just want to say thank you to like my entire team, right? I wouldn't have been able to do this without y'all, right? I just want to give them a shout out. Unfortunately, they couldn't be here today, but they are.
I'm a part of the team. Don't forget.
That's true. We have Mr. Mohammed. Yeah.
You got supportive instructors.
Yep.
Very supportive instructors.
All right. Who's doing your welding?
We have 3 people in our team that are currently learning how to weld in the shop at University of Houston Sugar Land.
Good.
And then we also have you as a backup.
Okay. Give us a call if you need something. Might be able to machine some parts for you too. So I see too many senior projects that don't get finished. So I'm counting on you guys, or I want a full refund.
Absolutely. We're dedicated to make this come alive. Absolutely dedicated.
Good. All right. Well, when's this semester over? Is this a fall semester? Is the end of this or at the end of the summer?
This is the end of fall semester.
So you got all the way till next Christmas
Yes.
to finish this. I got hope. And then you've already got a track lined up, and you'll have actuators here pretty soon.
Hopefully.
Yeah. I think at a minimum you ought to be able to control this with a joystick, and if you manage to get it to go full software control, that'll be even better. But what I'm looking for is data. If I just see data on improvements in lateral acceleration, I'm all in.
Awesome. Well,
All right, you got your homework?
Yeah.
yes, sir.
Well, thanks for coming on today. It's been a lot of fun, and we're going to be looking forward to hearing your results, and I want to see it quantified numerically.
Yes, sir.
Thank you for having us.
We appreciate it.
Thanks for coming.